Hello, everybody. We're going to talk about capacitors and some of their properties and what they look like and so forth. This is a variable capacitor. These are the negative plates. They're all connected together by this shaft here. Shaft's connected to that frame, and that's going to be its ground. These are the positive terminals here. And when you turn this counterclockwise as it sits now, it will make these plates engage more of these plates here. In other words, there'll be more area between, oh, I said that wrong, not more area, but there'll be more plates in proximity of each other, which will increase the capacitance. There's an insulator between these. It's just air, and that's all the insulation they need. This is a very low voltage capacitor. It's used for tuning radios, actually, tuning old analog type radios. This is a surface mount capacitor. There's a lead here. The solder goes on that. Solder goes on here. There's its positive lead protruding. There's this negative lead just protruding a little bit. Some more information is this is 220 microfarads, and they're in microfarads because they're so big. It's just a characteristic of size, and it's rated at 6 volts. Here's a bunch of his cousins already soldered down to a board. These are a bunch of different size electrolytic surface mount capacitors. Now you can see that these have been soldered down right here, right here. And the negative leads are just out of sight. This guy is a little bit different. He's a tantalum capacitor. He's got polarity. That's its positive lead. I don't know if you can see that says plus, that says minus. That's the plus lead. All of these positive leads are out here. All the negative leads are in the back, and the negative lead is marked by this big black stripe. Some of them have just little smaller stripes. The positive side has been chamfered. The plastic has been chamfered. It's angled. This little guy is known as a feed-through capacitor. That's used to trap radio waves inside of a box. This terminal goes all the way through the center of this capacitor. If you put your ohm meter on here, you'd read 0 ohms between that point and this point here. That's essentially one rod. This is the negative terminal, and it gets screwed into the metal body of the radio system. You can get DC in to the radio transmitter or receiver this way, and the radio waves can't escape because they get absorbed and get shunted to ground through this capacitor. This little guy is another capacitor, and just looking at it, it's 1 microfarad rated at 400 volts, and that J is a tolerance letter, which I don't have that tolerance table in front of me right now. This little guy, another capacitor, rated in microfarads. Somewhere on there, there's going to be a voltage rating. Anyway, that's 0.15 microfarads, and they went to the trouble of telling you what's inside. Aluminum, paper, and oil. Oil's on the paper, and that's part of the insulator, and the aluminum is the plates. Now here's his cousin all taken apart. See how the leads come out one side and on the other side? Well, this next illustration is a capacitor that gave its all for this demonstration. There's the 2 leads coming out of the capacitor. Now one of those leads is connected to this plate. The other lead is connected to this plate. And the paper separates plates completely. That gives us our capacitor, and it does look like these plates or these insulators, these papers are covered in oil. Looks kind of greasy to me. Here's a couple of non-mutilated Electrolytic capacitors, like we just saw on the other slide. 470 microfarads. I can't read the voltage rating back here, but I know that does mean volts. It says 5. Maybe it's 55 volt rating. I don't know. But they really are talking about its temperature rating. It can stand 105 degrees centigrade. This little guy, an electrolytic capacitor, the negative lead is over there, and its values right there. This one is 0.1 microfarads. This one has that is a temperature coefficient for that capacitor. We'll look at that sometime later. That looks like it's also zero point 0.1 microfarads here, but the voltage rating is 250 volts. That appears to be all the number 2 on there, and it's real tiny. It's going to be down in the picofarad range. This one's 10 microfarads at 35 volts. Can't see the polarity marker on this one. Turn around, show us your polarity marker. These little guys are low value, 1000 picofarad, plus or minus 5%. The insulation value on this is 500 volts. Don't put more than 500 volts to it because it'll break the insulation down inside. Silver and mica are what makes this up, and it says SM. These are typically found in radio and RF applications. These two little guys, that's another 0.1 microfarad capacitor. Its tolerance is J. And the 2A I'm not sure about, but if you were to look that up on a data sheet, it would spell it out for us. This big guy is a gas-filled specialized capacitor. This capacitor happens to be most typically used in power filters, DC power filters. At 11,000 microfarads, that's quite a bit of microfarads to have in a capacitor. There are some that are very much larger. Oh, and the polarity marker isn't up here. It's probably on the side over here somewhere. Oh, the other thing is this little dot. If you were to happen to see this thing missing, that means the capacitor couldn't handle the voltage and things started to boil, get hot, and it gassed out. That's a pressure relief valve. It's a single use pressure relief valve. If it's gone, throw this guy away, replace it. These are tantalum capacitors. The positive terminal is over here. I know you can't see it very well. Well, let's see. Yeah, that's the positive terminal here. The negative terminal's here. 47 microfarads at 35 volts. Oh, one lead's longer than the other. Generally speaking, the positive leads are longer, but it varies from manufacturer to manufacturer. So don't trust the length of the lead. Always look for the markings on the body of the component. This little guy is another variable capacitor. He's typically found in little AM transistor radios. You can see some of the plates back here. These little guys, and I mean little, are also capacitors. They're also surface mount. I don't have a photo of them being mounted on a circuit board. But as you can see, this is a human finger, and this little guy is just that, very tiny. Typically, these two are used in RF applications, very high frequency RF applications. There's another tantalum capacitor. They marked the lead plus 2.2 microfarads at 25 volts. This one's rated at 16. That one's rated at 6. That's the positive marker here. That's the plus side. This is a 1 microfarad ceramic type capacitor. It's been dipped and it's got a couple leads coming out. Doesn't have any polarity to it. And old Doc Brown, he got in here somehow. Don't understand how that happened. This is a very special variable capacitor. It's gas filled, and how we know that is they decided to pinch this part off. This is its contact terminal. That is a bellows on the inside of it. So they can change this distance by pushing on this rod right here. It's most likely done with a stepper motor to tune this capacitor to make it more or less capacitance, whatever that rating happens to be. These are very thin surface mount ceramic type capacitors, and that's no illusion. They are that thin. And that just about covers capacitors for today.